In junior high school mathematics, you will encounter solving linear inequalities for grade 7, solving quadratic inequalities for grade 8 and for grade 9. This time, let us familiarize the different inequality symbols. First, we have the greater than, the less than symbol, greater than or equal to, and less than or equal to symbol. Aside from grades 8, 7, 8, 9, for grade 11, you also have the rational inequalities. So you better watch this video and understand different signs in our inequalities. To write our final answer, we have the interval notation. Okay. This is very important. You're going to write your final answer in interval form or interval notation. So how to do the interval notation? Let's say we're going to check or to test our final answer. So we're going to use the number line to test our final answer. Let's say in our final answer, we have this output. Okay. So -1, we have a hollow or a circle here, then going to positive infinity. So before we write that in interval form, let us first familiarize the different symbols that we're going to use. Okay. If you will encounter the symbol, this is what we call the open. And the shaded part is what we call the close. If you encounter the open symbol, we will use the open parentheses or the close parentheses. And if our symbol is close or the shaded one, we're going to use the bracket sign. Now, let us write this in interval notation. So, open to -1. So, open and write the number -1, comma. Then we're going to positive infinity. So, positive infinity. Now, what are we going to use? The open or close? Since we don't know or we do not know where it ends because this is infinity, we're going to use the open symbol. So, open to -1, that means -1 is not included. Then going to positive infinity. Another example. Let's say this is our number line. Then this will be our inequality. This one. So we have in -1 and in +2. So let's start on the left side of our number line. This is going to negative infinity. So since we do not know where it ends, so this will become open to negative infinity. Okay. Then -1, it is shaded. So that means -1 is included. So negative 1. Since this is closed, we're going to close bracket. Now we have another answer on the positive side. So we're going to use union. This is a grade 7 lesson, union. That means it is included. Open to positive 2. Open to positive 2. Then we're going to positive infinity. So this is also open. Did you get it? Now, another example. What if we have 0, 1, 2, negative 1, negative 2. What if your inequality is close to negative 2 going to close to positive 2? So since we are close to negative 2, then also close to positive 2. So positive 2, then close. Okay. Now, I want you to try the following example. Try to write the following into interval notation. What if you have, for number 1, so this is 0, 1, 2, 3. Negative 1, negative 2. Open to negative 2, then open to negative 3. You can pause the video if you want to try this one. And after answering, you can resume watching the video. Now let us try. Open to negative 2. So open to negative 2 and open to negative 3. Open to positive 3. Positive 3, that is open. That means negative 2 is not included and 3 is not included. But 1.99, 1.98, negative 1.97, negative 1.99 is included. Positive 2.99 is included, but not positive 3. How about this one? 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3. Okay. I want you to solve number 2. Get your notebook, then try answering. You can also pause the video. If you are done, resume playing, then let us check your work. So we are going to negative infinity. So open to negative infinity and negative 1. Close or open? So shaded, that means we're going to close to negative 1. Union, close to positive 3. Close to positive 3. Then we're going to positive infinity. This is positive infinity. We're going to use the close parenthesis. Okay, that is the inequality and the interval notation. Again, this is very important. Our topic is solving quadratic inequalities. For grade 9, you have your quadratic equation. But what if we have these quadratic inequalities? Let's say we have problem number 1, x squared plus 7x plus 10 is less than or equal to 0. Okay. So if it is equal to 0, that is easy because we already discussed that in our equation, quadratic equation. But if we have less than or equal to 0, so just like solving quadratic equation, we're going to factor our trinomial. To factor this, our shortcut is the product of factors of 10, which is, if you're going to get the sum, that must be equal to 7. Obviously, that is 5 times 2. So x, positive 5, positive 2. 5 times 2 is 10. 5 plus 2 is 7. Now, after getting the factors, find the zeros of our quadratic inequality. So, our zeros just equate to 0. So, x plus 5 is equal to 0. Then x plus 2 is equal to 0. So, x is equal to negative 5. And x is equal to negative 2. This will be our zeros. Now, next step. You need to plot in our number line. Okay. Let's say this is our number line. We have 0, positive 1, positive 2, positive 3, positive 4, and we have the negative numbers, negative 1, negative 2, negative 3, negative 4, negative 5. Let us extend negative 6. Okay. After getting our number line, locate negative 5. Where is negative 5? Negative 5 is here. And negative 2. Negative 2 is here. Now, let us test our inequality. Less than or equal to 0. So, let us check the numbers on the left side of our negative 5 first. Of course, on the left side of the negative 5, we have negative 6, negative 7, negative 8. So, let us check one number on the left side. Let us check negative 6. Or if you want negative 7, that's okay. So, copy the factor. So, that is x plus 5 times x plus 2 less than or equal to 0. So, I will use negative 6 to test or to check. So, negative 6 plus 5, and just substitute the value for x, negative 6 plus 2. It's less than or equal to 0. So, negative 6, I just substitute to x. Okay? Then simplify. Negative 6 plus 5, that is negative 1. Negative 6 plus 2, that is negative 4. Less than or equal to 0. Negative 1 times negative 4, that is positive 4. Less than or equal to 0. Is 4 less than 0? No. So that means this is false because 4 is greater than 0. So that means all the numbers on the left side of negative 5 is not included because we have the answer of it doesn't match. So this is false. How about in between negative 5 and negative 2? Let us choose negative 4 or negative 3. If you want negative 4 or negative 3, that's okay. Just pick one number. Okay, I will choose negative 4. It's up to you. If you're going to choose negative 3, it's okay. So I will choose negative 4. So I need to substitute as our x. So negative 4 plus 5 and negative 4 plus 2 less than or equal to 0. So negative 4 plus 5, that is positive 1 times negative 4 plus 2, negative 2, less than or equal to 0. Now we have 1 times negative 2, negative 2 less than or equal to 0. Is negative 2 less than 0? Yes. So that means this is true. True. And last one. Let us check the numbers on the right side of negative 2. You can choose between negative 1, 0, 1, 2, 3. It's up to you. But I'm going to choose 0 because this is the easiest one. So I will substitute 0 to our x. 0 plus 5. 0 plus 2 less than or equal to 0. 0 plus 5, that is 5. 0 plus 2, that is 2. Less than or equal to 0. 10 less than or equal to 0. Is it true or false? This is false because 10 is greater than 0. Take a look at our answers. False, true, and false. That means in our inequality, these numbers satisfies our inequalities. So, as our final answer, using interval notation, so we're going to close. Why close? Because that is equal to negative 5. And we're going to close to negative 2 as our final answer. Our problem is x squared minus 2x minus 15 is greater than or equal to 0. Our first step, we need to factor our trinomial. So our factors are factors of negative 15, wherein the sum is negative 2. So that is negative 5 and positive 3. Negative 5 times positive 3, that is negative 15. Negative 5 plus positive 3, that is negative 2. Second step, find the zeros of the quadratic inequality. So our zeros are, just equate to 0. X plus 3 is equal to 0. So x is equal to positive 5 and x is equal to negative 3. So this will be our zeros. Take note, that is not yet our final answer. Now, using our number line, locate positive 5 and negative 3. This is our number line. 0, 1, 2, 3, 4, 5, 6, so on. So positive 5 and negative 3. Negative 1, negative 2, negative 3. Okay. Then negative 4, negative 5, and so on. And let us check whether the left side of negative 3 satisfies our inequality or not. So pick a number on the left side of negative 3. Negative 4, negative 5, negative 6, negative 7, it's up to you. Let us choose negative 5. Copy the factors. X minus 5. So my x is negative 5 minus 5 times x is negative 5 plus 3. Greater than or equal to 0. Let us check if this negative 5 satisfies our inequality. Negative 5 minus 5, this is negative 10. Negative 5 plus 3, that is negative 2. Greater than or equal to 0. Negative 10 times negative 2, this is 20, positive 20. Greater than or equal to 0. Is 20 greater than 0? Yes. That means this is true. Okay. Next. Now, let us choose between the following numbers. Negative 2, negative 1, 0, 1, 2, 3, or 4. To check whether it satisfies our inequality. Let us pick the easiest one, the 0. So, change x to 0. 0 minus 5. 0 plus 3. Greater than or equal to 0. 0 minus 5, this is negative 5. 0 plus 3, positive 3. Greater than or equal to 0. Negative 5 times positive 3. Negative 15. Greater than or equal to 0. True or false? Negative 15 is less than 0. So this is false. That means the following numbers does not satisfy our inequality. Okay, let us neglect those numbers. Now, let us try the numbers on the right side of positive 5. Okay, choose 6, positive 6, positive 7, positive 8, positive 9, positive 10. It's up to you. But I will pick the smallest one, the 6. So x will be 6. So 6 minus 5. 6 plus 3 greater than or equal to 0. 6 minus 5, that is 1. 6 plus 3, that is 9. Greater than or equal to 0. 1 times 9, that is positive 9. Greater than or equal to 0. True or false? This is true. So that means our interval notation, our final answer is, this is true. We're going to negative infinity. So open to negative infinity. Then negative 3. That means we have equal to negative 3. Open or close. So negative 3 is included because we have the equal sign. So we're going to close. Union 5. 5 is also included. 5 to positive infinity. This is now our final answer in our quadratic inequality.